Hello students, let's have a review session. For the review, I selected an actual exam problem that I used in fall 2020. This is a free file that I posted in Canvas. We have the exam problems and some hints and suggestions. Actually, here's a full solution, another full solution, but those are rare cases. Most of the time, I just put suggestions and hints, not a full solution. And with these, at least you can try. Now, assuming everybody tried at least half of the problems, let's have a deeper discussion with this notebook here. Okay, let's go to the first problem, but here I don't have a lot to discuss. The data table for Dow Jones, S&P 500, and NASDAQ Composite Index. And here, 5-number summary for Dow Jones, which is the first column. So, disregarding the second and the third, you can just work out the first column, and you can get 5-number summary by sorting those out and knocking off the smallest, largest, and so on to get the middle, the median. And then from the median, take the upper half and then do the same thing, and lower half do the same thing, and that's how you can get a quartile. And minimum, first quartile, median, third quartile, and maximum. Those are all there. And here is the 5-number summary. Excuse me, this is a box whiskers chart. Here, above here, 5-number summary, and this is the box whiskers chart. Okay, I just took it from a student. And this too came from a student. Same student actually. And this particular student selected 5 class intervals. And if you select 6, 7, or other class intervals, that's going to be okay. But if you have just 2 or 3, that's not good enough. You see, 5-number summary already has 5 numbers, and that's considered bare bone minimum. So if you're going to do histogram, common sense tells you that you should have at least 5 intervals here, 5 rectangles, because histogram should give you a little bit better understanding than 5-number summary. And if you have 3 boxes, then it's worse than 5-number summary, so it's not doing any justice. Anyway, here's a histogram, and when you select an histogram, when you select those class intervals, make sure the widths remain the same. In this case, let's see, yeah, same width was selected. If you have variable width, then the histogram becomes a whole lot tougher. You have to use the average instead of the height, and that's going to be a lot harder. Okay, let's go to the next problem, linear regression. The following table summarizes the mean, the standard deviation, and the pair-by-pair correlations of Dow Jones Industrial Average, the first column, and S&P 500, second column, and NASDAQ Composite Index, the third column. And it is for 1 year, October 14, 2019 to October 13, 2020. Now, let's look at these. Mean of Dow Jones is this, mean of S&P 500 is this, the mean of NASDAQ is this, and so on. So mean and standard deviation, you can easily see which is which. Now let's go to correlation. The correlation for Dow and S&P, so we are looking at these numbers, and these numbers are the same. Of course, we are looking at Dow and S&P or Dow, and we are looking at those pair. So for NASDAQ, no consideration here. Here's another correlation, S&P and NASDAQ. These two are the same, of course, and Dow is not related. And third, Dow and NASDAQ, so this one and that one, those are the same. And the third column doesn't do anything here. So that's what it means by pair-by correlations. Okay, using all this data set, and also using this number, you have to do some regression prediction. Find the best point estimate of S&P 500 index, the second column, when the Dow is about 28,000. So the first column is 28,000. Well, let's see, the mean is 26,500 something. So this 28,000 is above the mean. So you can expect this is going to be above the mean as well. So the final answer should be bigger than 3,100 something. Look at the correlation, and correlation is pretty strong, 0.91 something. So yes, very strong correlation positively. So you're going to get larger than 3,100 something, significantly larger. All right, let's begin. And here are two suggestions. First suggestion is to use my method. Just a one-step process using this formula, which is based upon an equation of the line given by a slope point equation, running through the average point x bar y bar, and this is a slope. All right, now you have to put in all those numbers in, and which is which? Good question. You know the formula, yeah, but you don't really have anything unless you know what to do. 28,000 is the x value, so that should go here in place of x. All right, now all the other numbers are coming from the table. Now what is x bar? What is y bar? Bar means the average, mean, so it's got to be means, either this or that. You see, this is about S&P 500 and Dow, so third column doesn't do anything. So this or that, which is which? Sx and Sy, those are standard deviations, so they're coming from the second row. Which is which? And how about R? Well, the same, so it doesn't matter which way you select. This quantity is going to be 0.91 something anyway. So 0.91766. Okay, that much is sufficient. As for Sy, you got to do something here. As for Sx, again, you have to find appropriate number. Same for this one and also that one. Good luck. Now here's the second method. Second method is the method of textbook and also MyMathLab, and it follows three-step method. Previously it was just one-step method, but this is three-step method. First, find B1, and B1 is R times Sy over Sx. Now you have to go to this table and find out which is which and plug in, and run your calculator. You're going to get B1 value. That's not the answer, that's just step 1. Let's go to step 2. B0 is y bar minus B1 x bar. Now B1 is the quantity you just found out in step 1. And as for y bar and x bar, those are the means, averages, so either one of these two. Which is which? Put those in and do your computation, you're going to get B0 value. Still not done yet. This is step 2. Let's go to step 3. And here you go. This is based upon the slope-intercept equation of the line. So intercept, y-intercept, B0, which we calculated in step 2, and slope, B1, that's something you got in step 1. And then how about the x value? The problem gave you 28,000. So plug that in here and run your calculator, and you're going to get this y hat, the point estimation, the regression prediction. So which do you prefer? The three-step method or a one-step method? Personally, I prefer the one-step method. It's simpler, there's less room for mistakes. But MyMathLab and our textbook are both using the second method. If you prefer, I'm not going to strip it. But I can tell you this. The student who used the first method usually scored better. That much I can tell you. But I'm not going to stop you from using whatever method that you're using as long as you're doing it right. Now, as for the other two problems, same as before, except that for second problem, part B, you're looking at NASDAQ and S&P 500. So you're looking at these two and disregarding the first column. And for part C, you're looking at Dow and NASDAQ. So you're not looking at the second column. So cross second column out of your mind and look at the first and the third column. One more hint. Whether you use this one-step method or three-step method, you gotta know X value. And X is given in the problem set. Not from the table, it's coming from the problem. X is number you know, and Y, or Y hat, is the regression prediction. So, in this particular case, first problem, Dow is given as 28,000, excuse me. So that's X. So Dow Jones is X. X is this one. And then Y is S&P 500, this one. Now let's look at part C. NASDAQ is given as 8,500. Yeah, so this is X. And Dow Jones is something you want, so that's Y. These are Y's. So for each problem, you have to set appropriate X and Y. You see, these numbers here, X bar, Y bar, SX, SY, R, those are not carved in stone, basically. For each problem, you have to make appropriate adjustment, which is X column, which is Y column, that changes from one problem to another. So how do you adjust it? Well, you actually have to sit down and try. Good luck. I'll stop here, and I'm going to discuss the other problems in separate videos.